today I want to talk to you about this. This is a toolbox, and it actually is a representation of your toolbox, because we all kind of have a toolbox. Those are the kinds of things that we already know, the frameworks, the tools, the methodologies. And these are the things that we will use whenever we face a problem. We grasp to our toolbox, and we try to take whatever we can out of it. And that's cool. And we should always be working on that toolbox. And there's a very good reason why we should be working on it on conferences like today, and that's called the half-life. Does anyone know what a half-life is? Yeah, sure. Up front?
Yeah, so the half-life is the time it takes for a substance to reduce.
Yeah, so a half-life is the time required for a quantity to reduce to half its initial value. So I'm a Belgian. When we drink a beer, the pint is gone in like, half the pint is gone in like a minute. But there's also a half-life of our IT knowledge, unfortunately. And that's what I want to talk to you about today. Does anyone know what the half-life of your relevant IT knowledge is? Who wants to wager a guess? Yeah, go ahead. 5 years. Anyone else? 6 months? I heard 6 decades. Did someone really? Wow. Why would we even have conferences? Like, we can have a conference every 15 years and we would be fine in that case. Unfortunately, it's 2 to 5 years. So every 2 to 5 years, half of everything you know is not that relevant anymore. So I've been in the IT sector for 9 years now. Let's say a lot of the things that I had to learn in the beginning just aren't used anymore. So that's what I want to talk to you about today. So we're going to go through 4 different topics, actually. Because we need to keep up to date, it's really important that we only have a limited amount of time, that we spend that limited amount of time on things that are really useful. So I have 4 topics I'm going to go through. And actually, the first one is finding the right things to learn about. And finding the right things is a very tricky subject, because it could mean a lot of things. And this is what, for me, the IT sector sometimes feels like. So they say to you, you need to learn all this, or you could learn all this, pick something. And that feels, I see a few people nodding, this feels enormously overwhelming. Like, this is actually what happens in our sector. Constantly new frameworks, new tools, all these new things that we need to learn, and it goes at a crazy pace. So when I say to you that I'm going to talk about the right things to learn about, it sounds like I'm going to give you a clear answer, but I can't, because it actually depends on your context. What I can tell you about is something that I learned during my teacher's degree, because before I went into IT, I got my teacher's degree, and this is one of the simplest models that they had that, for me, had a lot of impact. And it's so ridiculously simple that I'm going to share it with you today. Because you have basically the inner circle. That's everything you know. And right outside of that circle are things that you can learn at that moment. So you have the prerequisites required to learn that new thing. But if you go one step further, then you come into a zone of things you can't learn. And that's very abstract, so I'm going to give you a concrete example. If you know HTML styling, so you know that you have an HTML tag, and you can have a style attribute, well, then the next step is probably CSS. You could probably learn CSS if you know about the style attributes and how it has an effect in the browser on those HTML elements. But something that you probably can't do yet is CSS animations, because that's just a step too far. You first need to take that step back. So whenever you try to learn something new, try to map this out for yourself. Do I have all the prerequisites? Because the prerequisites are usually at the top of a tutorial, and we skip those because that's documentation, and who wants to read documentation anyway? But it's very important that maintainers put a lot of time in writing that stuff. So make sure to check on your own circle. And those circles are called the zone of proximal development. So that's what is the next step in your personal evolution that's within your proximity. That's what it refers to. And the reason why that simple model works is actually because of a concept called cognitive load. So who knows about cognitive load? Not that, since this morning, so you went to Simone's session. Excellent, excellent. Well, if you paid attention this morning, then sometimes you need to repeat something a couple of times before it really goes to your long-term memory. So that's what we're going to do right now. So you basically, Simone said this morning that in your working memory, You can have 5 to 9 items in there at the same time, so those are all concepts that you can store in your head. Since 5 to 9 is a bit weird in the diagram, I took 7 right in the middle. And your working memory actually gets filled with load. So those are things that like stretch you, like a CPU. And there's two main, actually there's 3, but I'm only going to highlight 2 here. 2 main sources of load. And the first one is the intrinsic load. That's just intrinsically how hard a task is. If I ask you to multiply 2 times 2, it's 4. Like, you almost trigger no effort in your brain because it's just 2 times 2 is 4, easy. But when I ask you to make like a differential equation that could send us to the moon, yeah, that's just, intrinsically, that's a way harder task. So that takes up, yeah, a bit of effort. But then there's also the extraneous load. And that's load that you get because the instruction techniques aren't as correct. So what could that mean? If you've ever, I hope it's not today because I don't want to blame one of the, or shame one of the other speakers, but if you ever see a presentation with a lot of animation, I don't know if you've ever seen a teacher do that, but if you have a lot of animation in your slides, that's actually extraneous load. You have more difficulty to pay attention because there's so much happening. Actually, extraneous load is also what happens when text on your slide is too small. You're forcing the viewer of your slides to really focus on what's being written there, and all that effort that goes into, what's that thing? That's actually effort that your brain is not using for something a bit more useful. So that leaves us with the problem, because if we can only have like 7 things in our head, Java is more than 7 things. So how do we do that? Well, that's where something awesome comes, and it's a little hack, basically. This is like a node of different ideas. And a node of different ideas is actually called a schema or a schemata, and that's a bunch of different ideas connected together. And those actually don't take up as much effort in your working memory. So when you're doing Java, you're hardly thinking about classes anymore. You just, oh yeah, I need to make a class, da, 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 da. And the more fluent you get, actually the more of these schemas are in your long-term memory, the easier it becomes to do, well, tasks that seem like magic the first time that you touch a PC. So why all this explanation? Well, if you want to learn new things, those zones are actually so this was the big idea. These zones are really a practical implementation of something that you can draw on a whiteboard for yourself, for your junior developers in your team, even for your boss or whatever. That helps explain this a bit. So it gives you a lot more context. Am I learning the right things? But if you look at this, and let's assume it's true. I have the research to back it up, but I can't show you all the research. If this is true, then it's really important to put the right things here. Because the more useful schemas you have in your long-term memory, the more that you can bank on them and the more that you can use them. And something that's really important there is that the technical implementations fade faster than the concepts they are based on. So what this means is, I see a lot of junior developers go, oh, I want to learn Angular and React and Java and C#, and they want to learn so many things, but they only, I see, is that laughter recognition? Maybe? Okay, so they try to learn so many different things, but they forget to focus on the concepts, because if you look at the concepts of a language like C# or a language like Java, the concepts are kind of the same. So there are things that you could learn that have way more value for you on the long term. And those are these things, concepts like object-oriented programming. That's something you learn for Java and C#. Functional programming, reactive programming. Good test-driven development can give you a lot of benefit in any programming language that you switch to, even just as a methodology. Domain-driven design. These, especially design patterns and clean code, are really useful. Because if you saw the previous diagram of all these schemas that you have that you can easily load in your working memory, so let me just jump back here. If you know a lot about design patterns actually become these little blocks that you can easily recognize in code whenever you see it. And that makes code way more readable just because you know, oh, look, this is like an observer pattern, or this is like a singleton pattern. And it makes it easier to read code, even if you've never seen it before, just by knowing your design patterns. Now I have this slide here. That's because I know that a lot of people have difficulties with those circles, determining what's the next valuable step. And actually, if you, who knows about Coding Coach, by the way? Almost no one. Oh, Richelle, okay, nice. So codingcoach.io is a free platform where developers donate a bit of their time to whoever wants it. So you can either join the platform as a mentor, where you give some time for free. I do this, for example. Or you can join as a mentee to find someone to help you map out your career. So either you can find someone that helps you with a very specific Java question. You can find someone that helps you with determining, hey, what should I be learning next? Because I'm having a bit of struggle. It's a really great platform, and I can really recommend it because for me, I was able to help some people in Ghana, in Africa, people that don't really have access to a lot of really good educational tools. And it just really warms the heart to be able to help those people. So if you can, I know that there's only 4 Dutch Java developers that are mentors. So if you can, please. I actually, if you sign up, I have Belgian chocolate here somewhere that I will be handing out to you, if you can prove to me afterwards that you signed up. But that's about learning. That's about learning the new tools. Then you still need to learn how to apply those tools in a correct way. And that's where I see a lot of people have a bit of issues, because they have issues applying what they've learned. They've learned something, and then they're like, yeah, but what am I going to do with this? Like, how am I going to ever apply this? Maybe you've had that feeling today when you were at some talk. It's not always evident how you can apply the things that you learned, and sometimes people just make mistakes when they try to apply it, and that's what I want to talk about now. This is another diagram that I got during my teacher's degree, and it actually explains how teachers are taught to teach you. That's a difficult tongue twister. So this is basically the structure that most lessons or an array of lessons are structured in. And actually, you begin at the bottom. You need to be able to remember something in order to actually use it. You need to understand it. But if you look at what our sector actually wants, what you're being paid for, that's the top part. We're being paid to create. We're being paid to evaluate. We're being paid to analyze. But the very important part in the middle is the applying part. So you can learn a lot of different stuff, but you don't know when, in what context, and how you are going to apply that knowledge. And actually, it's not as valuable as it could be. So the session is called Learning Through Tinkering. So I have to give a sort of a definition, because tinkering is not a word that you hear that often. So tinkering is experimenting with ideas, frameworks in a fully integrated environment to fully understand their capabilities. In short, it's just apply what you learn. You learn a lot of stuff at conferences, but then if you go home, next week, you will have forgotten 97% of it, if you don't actually actively go do something with it. So then, yeah, my colleagues asked me, hey, Tom, how do you apply your knowledge? What kind of stuff do you do? What are the things that you need to pay attention to? So I decided that I would take a couple of my pet projects, like the things that I used to learn. I'm going to show them to you, and I'll tell you a bit about the history with those projects and how I failed, where I succeeded, and so on. Before I continue, there are some live demos in here. All the code is available on GitHub. It's already online, so don't worry about too much about understanding every code in depth. The first thing that I really want to tell you today, if you're going to apply something, so if you have something that you want to study and you want to go and build something, really limit yourself. Because if you're anything like me, you want to do a pet project with a database you've never used, with a framework you've never used, preferably in a programming language that you've never used. And that takes up so much of your working memory that it just, poof, it just doesn't work out. So there is actually real power in limiting yourself. And the way I did that was by building a little project. Does anyone know what this refers to? Yeah? Come again? Yeah, it's the companion cube. So this is from the Portal video game. So I decided, you know what? I'm going to make a small demo video game based on Portal, because that's one of the games that I like. And Portal is a really cool game. But I decided that I was going to do it purely with Java and JavaFX. So you need actually two things if you're going to build a video game, is what I learned. First, you need a framework. And the framework is basically your game loop here, where you can draw things on a screen. You have a game that runs and so on. And you have implementations for that. So actually, I didn't build any of this really myself. I just I found this online tutorial that helped me. And this was actually the first examples that I ever ran into where I was like, you know what? Programming to an interface instead of an implementation actually makes sense to me now. So that's one of those concepts that they drill into your head at school. Program to an interface, not an implementation, because then you can change the implementation. Well, in this case, the tutorial only gave you interfaces, and it was up to the reader, you know, those academical articles, like this is an exercise for the reader. It was one of those, and I decided to implement it with JavaFX. Code is available online. The second part you need is actually physics. And physics is not my favorite subject, but I decided to go for it anyway because I was really motivated, because this is something that I love. I love Portal, I love video games. So I decided, yeah, you know what? Let's try it. And it turns out that physics actually, in the pure basics, when you get them, when you get the domain logic behind it, they're actually not that super difficult. So what do you need? You need items, and those items have a couple of things. They have a location. So right now, this is my location, and my velocity, that's how fast you're going. That is 0, because I'm standing still. So now my velocity is pretty constant, because I'm walking around. And acceleration is the thing that makes you change your velocity. And basically, those are the only 3 variables that each object needs, and then you can do almost anything in physics. Because what does that look like? Well, so in games, you call something an update loop. So this gets called over and over. So what happens? Your acceleration gets added to your velocity, because if you keep accelerating, you means you go faster and faster, so your velocity goes up. Your location changes based on your velocity. Pretty logical. If you're going 50 miles an hour, why am I using miles? 50 kilometers an hour in one direction, then yeah, your location will change that much. And because it's in a loop, you don't want to endlessly accelerate. You put the acceleration to 0. Now, how does this acceleration change? Well, it's forces. So what happens is, each time you can apply a force. That could be gravity, could be something else. And that will change your acceleration. So that seems a bit... Once you grasp this concept, actually all the rest becomes pretty clean. I'm going to show you the actual little game I made. You know what? I'm just going to launch it first. And I can get a short drink. See? Simple game. You can really see that the gravity pulls it, so as the longer it falls, the more gravity is affecting it. And I just have a space button that will restart it. So what does this look like? I have a floor, just so the cube will stop falling at some point. I have a cube. I used to call it CC, companion cube, but I named it cube because people don't get the joke. And then I basically have an update loop. And what happens here is, as long as the cube, if the cube collides with the floor, then I just set velocity to 0. It stops falling. I don't have bouncing or anything. That's a bit too complex. And other than that, it's just cube, apply force, and I apply gravity. So this is what the code looks like. So no messing around with X and Y coordinates, which I used to do. Once you get the business domain, it actually becomes a lot easier. Now, you've seen the cube fall, so we can easily add another force. So let's say that we want to add wind, because we're going to blow the cube. These are vectors, so you have X and Y. So gravity will increase your Y coordinate, which will make the cube fall. But for the wind, let's change that up a bit. Now let's make the wind go one side. And all I need to do now is make sure that the wind is actually applied to the cube. And you can put really difficult game logic, like if it is in this zone, then apply the wind. But in concept, it all remains the same. So I have a force now, wind, and that's as easy as it's going to get. So let's see what happens. Oh. Now, the really cool thing is, because I made it a variable, it's really easy to change the wind intensity. Thank God, because it blew all over the place. So with just changing one variable, which is what you want, you're changing the wind, and I made sure that the wind kept going even if it's on the floor, but that's a detail. Because it's in one space, it's easy to change the code. So what I got from this project is, well, some fun, because I like this kind of stuff. But I also learned how physics actually work. And this showed me that if you know the domain of what you're building really well, that your code can be way more elegant than you expect it to be. So what does this have to do with limiting yourself? Well, everything. Because I'm pretty sure that I wouldn't be able to do this in a new programming language where I'm struggling with the programming language and at the same time learn a new business domain. And that's something that we should all keep in the back of our minds whenever we start a new project and we think, oh yeah, we're going to do it in Clojure. Okay, cool, cool. But your business domain is already complex. So you're going to mix a new programming language that not a lot of people are aware of with a new business domain. So that can get a bit, yeah, that's tricky. So whenever you try to do something for yourself to learn about something, make sure that you limit yourself. You know, when I would learn Clojure, I would build exactly the same thing in Clojure again, just to see. I know the business domain now, so learning a new language is something new, to really limit the amount of effort that my brain is going to have to do to learn these things. Something you should definitely do, because we all have I'm sorry, that was a sweeping generalization. Who of you has a graveyard of GitHub projects? So not all of you, but I'm sorry. Sorry, I won't generalize again. I'll do my best. Well, what you should really do is, even if just for your career, just look at those projects and what were the things that made me stop those pet projects. Maybe it wasn't a pet project, maybe it was, but reflecting on things is so valuable. And we do it with sprint reviews, but we don't do it with our own learning. That seems a bit, yeah. And I learned that the hard way. And this is unfortunately a true story, and I've masked a few of the names for obvious reasons. So, as I said in the beginning of the presentation, I first graduated as a school teacher and then got into IT, but I work at a company called InfoSupport, and what they did was a minor education. So students would come to us for 30 ECTS credits. If that doesn't ring a bell, it's just accredited training, let's say. And I was able to teach students for 4 months nothing but Java, which was awesome. But there's one thing I really hated about the class. We had to take attendance each morning. So every morning, hey, you're here, yeah, sure, blah, blah, blah. It was boring. So I decided, you know what, I'm going to automate this. This was kind of pre-GDPR, and I got approval from the students, so nobody freak out. But I decided, you know what, they come through the same door every day. I'm going to put a camera on the door. I'm going to film their faces, and then I train the machine learning model in something called Microsoft Cognitive Services API. So that's just a cloud API for face recognition. I thought it was working fine, and then I realized I had a problem, because a camera is a stream of images, and the API takes images. So I had to do something in between, because I didn't want to send each image to the cloud, because that would cost way too much money. And it seemed like a waste of time and space. So I decided, you know what? I'm going to use OpenCV. OpenCV is a video editing software, and it actually comes pre-packaged with a machine learning model to detect faces. And I was like, you know what? This is perfect. I can use that model that's shipped with OpenCV. I'll repeat, it's shipped with OpenCV, important for the rest of the topic. And whenever it recognizes a face, then I'll send it to the API, because then it's already recognized the face. So that seems like a reasonable trade-off. So me, happy, it was 3 a.m. I had to teach the class the next morning, and I was like, ship to production, it's working, because I tested it on myself and my mom and my cat, which didn't get detected, which you should always test the negatives as well. And then, yeah, it worked fine for like all students but one. And then, yeah, I was like, okay, so it doesn't work. This is a perfect teaching moment. Let's look together why the code isn't working, because it's really important. I find it at least very important that people see that I still fail and that it's okay to fail and that we can learn together. So after about 20 minutes with the student, we couldn't figure it out why it wasn't working. And then I decided, you know what? I can actually feed any image I want to the machine learning model, and we can see what comes out. So I found an image online. These are not my students. It's an image from online. And I fed it to the machine learning algorithm that was shipped with OpenCV. I'll repeat it again. And I repeat it again because it's very important to know that you should probably test something if you download it from online. So I know that we copy-paste our code from Stack Overflow, and that's like, it's kind of accepted. It shouldn't be, but maybe it is. But people are also copy-pasting machine learning algorithms and not testing them, and with a lot of enthusiasm going to the class and, hey, class, I have good news. You don't have to raise your hand for 2 seconds in the morning because I optimized it for you. Yeah. So this still haunts me, like genuinely, by the way. It was a really awkward moment, needless to say. But when I reflected on this and I really decided, you know what, I actually, one, didn't enjoy any of the machine learning part, and two, it's kind of dangerous. So whenever my boss asks me now, hey Tom, I have a cool machine learning project, I just go, no, I'm not going to do it. And if I'm going to do it, or if I'm being forced to, then I'm going to be the annoying one now that says, have you tried it with this image? Yeah. So this is why it's important to reflect on everything you learn or study about it. When you make like this little pet project, one, do you like doing it? Because that's a career lesson. I've tried building something with, what was it again? I think it was React, and I really didn't like React. It's fine. I tried it, I didn't like it. I don't have to do it as a career, I can choose. And that's a power that you all have. You can make little projects, try to see, hey, is this actually something I like? Because there's so many things out there. So you can choose something that you actually enjoy. So make sure that whatever you do, reflect on it. And this is actually a small exercise, maybe for the people that have a graveyard of GitHub projects. Go look at them and just see, why did I stop this? Was it just not interesting? What wasn't interesting about it? Or it became too difficult? Or people had expectations that you were going to maintain it, even though it was like a pet project? So something to keep in mind. The next thing is you need to be really conscious about your learning goals, because I don't know about you, but I see a lot of rabbit holes. As in, I work on something and then I go, oh, but that's interesting, oh, but that's interesting, and that's interesting. One example was the summer of 2016. Do you know what happened in the summer of 2016, oh, fellow nerdy people? Nobody? There we go. Was the summer that Pokemon Go was released. And I thought, I actually skipped the part of the presentation, it doesn't matter. So I thought, you know what, I want to reverse engineer this thing. Like, you had a lot of front ends that were connecting to the real backend. I was like, nah, I do Java. I'm going to build the backend and somehow hack this, the mobile app to connect to my backend so I can spawn Mewtwo and all these fancy Pokemon. So you learn a lot. So I actually found this blog, where this Reddit page, where they listed like the real reverse engineer people were. And I decided I'm going to take a look. And what did you learn? Well, apparently it uses RPC, so one endpoint for everything, which is no rest. It's not what I'm used to. But it gets in your brain and you start thinking about it. It doesn't use JSON, it uses protocol buffers. And in case you've never heard of protocol buffers, this is just a different serialization tool to serialize some text, your objects, send it over the wire. And actually, when you look at the numbers, it's pretty impressive how different it is. What Pokemon Go also does, it doesn't really invent, but it uses something called S2 geometry. So it doesn't choose latitude, longitude, because you can't actually index that stuff because it's two variables. But they use a technique to actually give every square centimeter on Earth a unique identifier. Now if you think, what does this have to do with your talk, Tom? Nothing. You need to be conscious about this because this was an example of a rabbit hole I went down to. My goal was I wanted to know how to reverse, to kind of build something that's similar. I didn't need to know all the details. So I just went into a rabbit hole. My wife found me at 6 a.m. in the morning. Like, what are you doing? I'm trying to make Pokemon Go in the backend. So it was a mess. So whatever you do, be very cautious about your learning goals if you try to actually study something. Because it's very easy to go down the rabbit hole of, oh, this looks shiny, I'm going there. So be careful. So let me just check up on the time. 13 minutes left. So what you can do with these kind of projects is try to experiment with alternative approaches to do something. And I decided I was going to make a little game again. Oh no, so original. But this time I did it with JavaScript. So that's like I wanted to learn a bit. How could I do this in JavaScript? Does anyone know this little animal, by the way? A Totoro. So yeah, so I made this little game, and I need to actually start the little game. So it's basically the same, it's just... See, and it can jump, it can jump. Yeah. There's no wind. But even better, I decided, you know what, this is boring. I'm going to... I discovered this. So remember my story about the machine learning that I really didn't like, that I just stole a machine learning algorithm online? This is a teachable machine, and you can actually build a machine learning algorithm pretty quickly by giving it a few examples. And not only that, I was thinking, what am I going to use as the controller for this game? And it just so happens that I'm a giant nerd, so I actually have a Totoro. So what are we going to do? Together. You could actually start creating a machine learning model. So you need to give it examples. And I thought, design-wise, to make it fly, that I would make them flap. So I need to detect two states, open state, closed state. And flying would be, I mean, it's the closest I could do to flying. So we need to have two classes that we can detect. I think it's open and closed. And I can actually use my, I need to make sure it's visible. I can use my webcam. See? Hi. To record a set of images that actually represents what you're trying to detect. So I'm going to now make a ton of examples using the open state. And the trick is, this is so silly because I need to hide so it doesn't accidentally so it doesn't accidentally make a me detector. So we're going to so open state. This is open state. Open, nice, close. Turn around, nice. Op. Okay. So now we have 126 samples of the open state. Now we're going to do the closed state. So that's basically the same. I need to hide behind the desk again because of weird demo reasons. There we go. Close. Try to make some diversity in the pictures. So, let's train the model. So normally training a machine learning model takes hours, days, weeks. I hope this would be a bit faster. So, oh, look at that. So what this actually does, it takes an existing machine learning model, cuts off the last pieces of the neural network, and then it only trains the last couple of pieces. So let's see. The default is open, so let me, close. Open, close. So cool thing is, you know when I said I had to write JavaScript? Export model. Oh, look at this. It's almost all there, but you can just upload it to the Google Cloud. They know everything anyway, so might as well. So then you get this nice URL, and in my code, I've actually made sure, let me just close this, that I have just a variable. Whew. I can feel the stress now, because now we're going to do it for real. Let me just, so that should, did it load the model yet? That's okay. Oh, there it goes. So, open. Close. Oh. So yeah, I only trained it with like one iteration of the images, so it could probably do better, but given the time, and pretty sure the plushie's tired now, so. So even though you've completely given up on something like machine learning, sometimes you can just try an alternative approach and see if that works. Because I don't want you to like try something like Java and say, ooh, I didn't like these swing applications. I'm never going to use Java again. Maybe try something else. So we're quickly going to go over the last couple of pieces. So some common mistakes while learning. That's too much stuff, the first one, which is actually what I talked about in the beginning. It's these circles. If you try to take up too much while learning, it could slow you down severely. So try to limit yourself to a couple things to learn at the same time. Cramming new knowledge. I know we all tried it in college and university. Doesn't actually work if you want to remember it long term. So be very careful when you're reading a book. Take notes, take your time, make sure that you reiterate them, read the notes. I know it feels like a hassle, but it's actually the best way to keep learning. And then, yeah, we have to talk about the big elephant in the room. Stack Overflow-based development, aka the copy-paste loop. So I know for those who were in Simona's talk, she also talked about this, but let me reiterate this. Let me copy-paste her presentation a little bit. Be very careful when you copy-paste something, and not only because you don't know what the code does, but because now it's yours. You have ownership now. Congratulations. Do you really understand everything what's in there? And for the things that you don't understand, are you looking it up? Are there any constructs that you don't get? You could even go to a Stack Overflow page and just look at the answers and see, hey, it's basically 2 times the same answer, but in a different way. Okay, that's useful information. But don't just copy-paste the first answer you see. That's just dangerous, and honestly, we get a bad rap that we just Google and copy-paste, so try not to be too much of the stereotype there. So, you're learning a lot here, I hope, today, at all the different talks. So how do you really get the most out of your knowledge? Share what you learn. I actually hope that next year one of you will be here on this stage explaining something that you love. Because what happens when you have to share, well, not really when you have to, but when you share what you learn, you actually are forced to dive deeper into the subject matter. So all those things that I showed you, those circles and those diagrams, that was from my teacher's degree 10 years ago. I actually had to go back and dive like, ooh, I remember something. That might be useful for this talk. But that actually forced me to learn more, read up about the literature again. There's this amazing book called The Programmer's Brain by Feline. I will put it in my show notes that I will put online later. It's a Dutch researcher from the TU Delft, and she's written an entire book about how your brain and code interacts with code and what it means if code is badly written, how that impacts your brain. Those are all the things I read to do this presentation. So whenever you do a presentation on anything, you are actually forced to learn a bit more about it. And that's the powerful part. And sharing could be anything. It could be giving a talk. It could be blogging. It could be anything, basically. And that's really what helped me learn more. Do some good. I mean, we have this amazing power to create cool stuff. When COVID broke out, I was able to help people in Belgium to set up a communication call, a video call. But no passwords, it wasn't safe at all, but nobody cared because people in retirement homes were able to click a link and it opened the magic call to their grandchildren. Security-wise, complete drama. But we were able to build something like that. So you have a lot of power as software developers, engineers, testers. I don't know all your roles, but you can do some good. Contribute to open source. Donate some time to Coding Coach. There's so much you could do. And be yourself. I mean, the coolest presentations I see are people that just come and explain something about something they're passionate about, and that's something I do. I mean, I brought a plush animal to my JSpring presentation because I'm just a silly person like that, and I like to share silly stuff with everyone. So just be yourself, and that's really cool because you bring your own story and your own energy, and that's what we need. So to close off my presentation, I think I'm quite on time. I talked to you about the toolbox, and we have to update our toolbox constantly because things go out of fashion. We need to learn new stuff, need to keep it up to date, need to keep it in shape. But in the end, who's responsible for that? What do you think? Who would be responsible? It's not your employer, it's you. So basically, even when your employer doesn't really give you incentives to go do it, just do it. It's your career. You're responsible to keep it up to date. You don't want to end up, or maybe you do because those COBOL programmers still make a lot of money, but do something that makes you happy and make sure that you keep it up to date and learn new stuff, and everything will be just fine. But make sure to know that you are the one who is responsible to keep everything up to date. So one more time, the circles. Center is what you know. There's a little area around it of things you can learn at the moment, and there's just some things you can't learn yet. So whenever you learn something new, those circles shift, and you will eventually be able to learn a lot more. But at some point in time, you're just limited, and you need to take certain steps. Now, let me tell you what happens if you don't do this correctly, and this sounds more dramatic than it is, but in a way. If you stay too much in the middle, you only do what you know. If you've made 50 Spring Boot applications, yeah, it becomes a bit boring. It becomes a bit boring, and you might get a bore out. Actually, this extra area where you're like 1 foot in comfort, where you know everything, and 1 foot in like the unknown, that could be a business domain or technology, that's the sweet spot. And unfortunately, I've been here. The outer zone, if you do too much new stuff at the same time, you will have a burnout, and trust me, you do not want to end up there. It's not a good place to be. So I went through all these topics with you today. So my call for action would be, if you do one thing, you've been here for a day, pick a topic that you enjoyed and go do something with it. Go build something, even if it's something small, or even if you blog about it, make a video about it, tell your friends about it at a coffee machine. Go do something with it. Because if hours and hours of watching Bob Ross doesn't make you a better painter, then hours and hours of sitting at JSpring and never doing anything with it won't make you a better programmer. That's the talk.